Okay, welcome back. ENG 360 VHDL. Let's see. In the last video, we did our 2-bit comparator. There was our entity block. We had 2 bits coming in on A. We had 2 bits coming in on B. We compared those 2 bits and we asserted A eq B if those 2-bit lines were equal. And we did an SOP implementation, which is what we show down here in our architecture block. Well, now what we'd like to do is simulate this guy. And if you look on the left here, you have your chip, your project, and then your VHDL file. Well, we need to add a test bench file to that to simulate. So I need to go to Project, New Source, and we have all kinds of things we can choose from right here. What we want is a VHDL test bench. So I typically call that TB, and what am I going to test? I'm going to test EQ2. All right, VHDL test bench. I prefix all my test bench files with a TB, so I know they're a test bench. And what am I going to test? EQ2. Click Next. And when you create a test bench file, it will give you a choice of all the VHDL modules to wrap a test bench around. Well, we only have one VHDL module here, which is EQ2, so I can select that. And then click Finish. All right, so now let's go over here to our Explorer window and notice. Now again, I have listing 1, 2 as my project. This is the chip I'm going to implement it on. This was the VHDL file I did in the previous video. Now I've got a test bench file that wraps that guy. Okay, and if you look down here, if I double click this guy, this is the file we did last time. Design summary. Well, this talks about all the kind of things that well, metrics and stuff that we can talk about later. Let's close that one. So really, on my lower tab here, I have EQ2, which I did last time, and then I got TB, test bench EQ2. If I click that, that's a file that just got stubbed out. So let's get rid of all the comments so we can kind of see what VHDL it actually stubbed out for me. And there we go. So that test bench, with me not doing anything, created a VHDL file that had my usual library stuff. That's good. We understand that. Now the test bench also creates an entity block, and it's empty. Okay, test bench entity files or entity blocks are empty. Then in the architecture block of a test bench file, you got to declare the component that you're going to test. Well, I'm going to test the EQ1 component. And if you look at this code right here, that's almost identical. If we go back to EQ2, if we look at the entity, the only thing that's changed is we replace the entity keyword with components. Let me go back to the test bench file. And there you go. There's your component keyword, but it's pretty much identical to the entity. So I'm declaring it right there. Declaring it. Okay. Now, inside my test bench file, I have local variables, but to distinguish those from my component I'm testing, I always like to prefix those with TB for test bench. Okay. And then here's an output variable. Let's prefix that with TB. Now, we're not going to use any clocks at this point in the course, so let's just delete the next 3 lines. Okay. So the part between my architecture and my begin statement is where I declare all my internal variables. I'm going to declare a component that I'm going to instantiate, and I'm going to declare 2 inputs and an output, okay, that are very similar to the component variables. Now here you have to instantiate the component that you declared. Up here you declare it. Down here you create an instance of it. This is the name, UUT. Okay, and then you have to map your variables. Well, the variables on the left are the component variables. They get mapped to the variables in this file. And that's why I prefix those with TB, just to kind of illustrate what's mapping to what. Now you could keep them the same names, but when you're learning VHDL, it's like I kind of like doing this so people realize, well, that's the variable of the component. This is the variable in the test bench file. Okay? So you have to instantiate it, create an instance of. Okay? Now again, we're not doing any clocks, so let's get rid of that. Okay. And now we've got our stimulus process. Well, this is where everything happens. Now this is a label right here. You don't need that. When you have multiple processes, it's always a good idea to put that in there. And let's see, what we can do right here is yeah, we could, well, let's see. Let's delete that. Now we need to set up our variables here. So let's set up our test bench variables, and we had TBA, and that gets set equal to, let's make that 0, 0, And then let's do the same thing for this TBB, and we'll set that to 0, 0. And then we'll wait for 100 nanoseconds. And then let's copy and paste that, and let's set these guys now to this. So in the first case right here, notice A and B are going to be equal, so we should assert the output. We're going to wait for 100 nanoseconds, and then we're going to change our inputs. Let's change our inputs to actually something different on both of them. Now they're not equal. Well, our output should deassert. Okay. All right, let's save everything here. Notice all my errors went away when I saved. And then once again, let's go back to our original component, and what we'll do is we'll compile that guy, behavioral check syntax. Okay, that looks good. Now let's highlight the test bench file. This is where people make a mistake. They don't have the test bench file highlighted when they do simulate behavioral model. But now that we have the test bench file highlighted, we have to do two things. One, we have to check the syntax before we fire off the simulation, and the next thing is we fire off the simulation. And a whole nother application came up, okay, and kind of manage the real estate here because I'm trying to do video on this screen. And then the icon that I want, I believe, is this one right here. Zoom to full view. And there you go. Notice that at this point right here, A, the test bench file, was 0, 0, and that got mapped to A of my my component that I was testing, and then B was also 0, 0. They were equal, and the output asserted. I waited roughly, how long did I wait? If I move that up to here, that's 100 nanoseconds. At 100 nanoseconds, I changed the value on A to what? Well, now the value is actually equal to 2, which is 1, 0. Okay, and then the value on B is equal to 1, which is 0, 1. Those are not equal. The output deasserted. All right. Now, notice how you've got these crisscross lines. Well, that's how you represent a data bus. And the value inside here is the value of the bits. This is a 2-bit data bus that goes from the value of 0 to 2. Let's actually put some more values in our simulation and rerun it here. Yep, I'll exit that. So let's go down to here, and let's just copy and paste. Make it real easy here. Let's see, we'll just copy and paste this guy all the way. Put a whole bunch of them in there. This is kind of the brute force. There's better ways of doing this with for loops, but we'll save that for later. Okay, so I've got 0, 0, 0, 0. So let's do 0, 0. We'll just kind of count in binary. 1, and then we'll do 2, then we'll do 3, then we'll do 4, then we'll do what? 5, okay, which would be that, and then we'll do 6, which would be that, and then we'll do 7, which would be that. And then we'll do 8, which is that. And then let's see, we'll do 9, which is that. And let's see if I wonder if I can get all of them in here. Let's try that 9. And then let's see if I do A, B, C, D, E, F. Okay, so go back up here to 9. Where was 9? There was 8. There's 9. So now I want 10 right here. So it should be 1, 0. And then 11 would be 1, 1. And then 12 would be 1, 0. And then 13 would be what? 1, 1, 0, 1. And then 14 would be 1. And this would be a 1, 0. And then 15 would be that. And then we're done. Yeah. So what I basically am doing is I'm just counting in binary 4 bits. And we should have roughly 16 entries if I did it right. All right. Let's save it. Now go back and check your component. All right, let's just double check that because maybe we changed something, maybe we didn't. All right, it's okay. Highlight your test bench file, behavioral check syntax on the test bench, and then simulate. And now if I typed in that truth table right, there should only be 4 places where the output asserts. Okay, only 4 places where the output asserts. Kind of drag this back to here, kind of clean up a little bit. Do zoom to full view, and let's see. The output asserts here. 0, 1, 2, 3. Okay, there's a 4, 5, 6, 7, 8, 9. All right. Well, we ran out of space here. Okay. Yeah, and that's because I have a default up there of 1 microsecond, and that's equal to 1,000 nanoseconds. So If we go back to here, what we can do is change this guy. Oh, how about, let me make that 50. Yeah, there's definitely way better ways of doing this, but we're kind of early on in the course here, so let's just do that. Let's change all those guys to 50. See if I can get it all in one shot here. Okay, let's save that. And again, let's compile everything. Go up here, the test bench. We'll compile that guy again. Make sure the test bench is highlighted. Simulate. Let's see if we can get a picture that shows my entire truth table. Okay. Shrink this down a little bit here. Bring this down a little bit here. Do a zoom to full view. Yeah, and that's the picture I wanted. Yeah, so when we had 0, 0, 0, 0 on both inputs, we asserted. When we had 1, 1, 1, 1 on both inputs, we asserted. When we had 1, 2, 1, 0, 1, 0 on both inputs, we asserted. And when we had 1, 1 on both inputs, we asserted. 1, 1 on A, 1, 1 on B, and we got a 3, and we asserted. So there's my 4 little ones if you go back to your truth table. And then we left the inputs at 3 and 3, 1, 1 on each line, and it just stayed there for the remaining of my time out to 1,000 nanoseconds or 1 microsecond. All right, there you go. I think we're good on there. Let's stop right there.